Hi, this is Open Up Resources, Algebra 1, Unit 3, Lesson 3. We are practicing how we can find the features of the function, and we'll point out the relative and absolute maximum or minimums, but we're focusing mostly on the absolute with these. So we're going to analyze each of the functions. They're presented in different ways, and then we're going to find their key features. So what we have here is a table that represents a discrete. So I just want to make sure this is noted. It is discrete, and it's defined from the interval of 1 to 5. So when I'm going to write my domain, we are going to have, we have to use set notation because we have a list of numbers. So my x values, or my n values in this case, are my 1 through 5. And I can't just go 1 through 5 because it is specifically 1, 2, 3, 4, 5. My range are all of these values. And notice they're in order, so that works out really nice that I don't have to really think about that. So 5, 10, 40, 80, and 160. My maximum is my biggest number here. So it is 160 at 5. My minimum is 5. That's my smallest y value at 1. My intercepts, I like to list them both. So, actually, I have none, do I? There are no zeros on any of it. So I'm going to actually just move this down and we'll put none. Intervals of increase. Well, looks like my y's are only increasing. So I want to be inclusive 1 to 5. And intervals of decrease, there are none. All right, so that's the first one. Pretty straightforward. Let's see what's next. So the next one, they're giving us a graph. All right, there we go, shrink that just a little so I can fit all this on here. All right, let's change colors on this one. Okay, any instructions? Nope. We're just working away. So domain. So my x values for this. It is continuous, so I can do my interval notation. It goes from, it looks like -8 over here, all the way up to 10. So, here we go. Oh, that one. And then my range. Oh, just to point out. So, not this one. It's a different one. Never mind. My range. So the lowest it goes, it looks like is -3. And the highest it goes is 5. Okay. My maximum right here is 5 at 10. And my minimum would be the -3 at 8. Oh, -8. Let's be specific there. Intercepts. I have one of each. So let's go ahead and make some space here. So my y-intercept is 0, maybe 4.2. Looks about right. 4.2. And my x-intercept is -6, maybe -6.5. 5, 0. Intervals of increase. So I'm actually going to draw on here. And I'm going to do my intervals of increase in purple. So I'm going to about right, looks like maybe about right here I'm increasing. Then we're decreasing. And it looks like, again, I'm going up about right here. So this is kind of my line. I didn't do that one very straight. to erase that and actually do one of these lines. There we go, so I know it's straight. And then I'm going to do my intervals of decrease. Let's do those in yellow. So I've got this space here in decrease. So go back to my text box here. Intervals of increase. I'm going basically from -8 to negative, looks like about -0.5. So my interval of increase, I'm including -8. I'm going up to 0.5, but I am not including that one. And at capital U, again at 7 to 10. So not including 7, but I am going to include 10. And my interval of decrease, do I have that in a color? Let's see if I got that color. Kind of got a purple for it. Well, whatever. All right. It's kind of our pinkish color. Increase. Decrease is really that 0.5, -0.5. Oh, that should be a negative. -0.5 to 7. And so I don't want to include either of those. 7, because they are not on the ends of either. Is this a function? Yes. Yes, it is. So let's put a yes on here. All right, because every point, every x value only has one spot past the vertical line test. All right, this one. I am going to go ahead and do a quick little table over here. Do this one back in green. So if I'm just going to start with 0 on here, 0 and 1, and then 1, 2, 3. So 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. I don't know if I'm going to get all the way to 27 on here, but let's just go ahead and do our graph. We know it's going to mostly be positive x's that I'm going to show, and it's going to be mostly positive y's that I'm going to show. So 1, 2, 3, 4, 5. Should we go by 2s? Yeah, if we go by 2s, we can probably get to 27. So it's 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, 1, 2, 3, 4, 5, 10. We aren't actually going to go that far, but that's all right. Gives us something to work with. So we're going to have a point at 0, 1 right here. And we're going to have one at 1, 3. Point right here. And 2, oh wait, oh my goodness, undo. Where's my undo? 1, 0, 1. We did it counted by 2s. We got to go right here. 1, 3 would be right here. 2 and 9 would be right here. 3 and 27. 2, 4, 6, 7. There we go. All right, and we know this one over here is going to be pretty low on that. So we're just going to kind of do that line going up like this. And we're going to hit the arrows. And we can go to the negatives. Doesn't say we can't. So let's go back to our domain. So our domain, oh, I got to find one of my symbols. Let's see if I can do one of my symbols. I think I have negative. Oh, there's infinity. Okay, so let's do this and see if we can put in a symbol. Okay, so our domain, we are going on forever for the x's and the negative, and we're going on forever in the positives. So negative infinity. this guy? Can we put him in here? Why is it not doing it? Duh. Can't add an infinity symbol in here. I don't know why it's not letting me do that. Ah, shoot. I thought that's how that worked. All right. Just kidding. I guess we'll take that out and we'll go back to I'll just write it. So in this case, our domain is negative infinity, comma, infinity. We could also do it as a set notation if we really wanted to. Our x is all real numbers. Just run out of space there. So then for our range, now notice our 0, we get really close to 0. We don't actually touch it. So we are not going to say it includes 0, but it can go on forever in the y's. So for the set notation, just to show, you could do y is greater than 0 for that one. All right, let's go back to our text box. Maximum. We will never hit a top one, will we? Because it's going to go on forever. Our minimum, we don't ever hit a minimum, but it does approach 0. So we are going to put approaches 0 on this one because that is really, it doesn't hit 0, but it approaches 0. Intercepts. Let's get both of them on here. Well, we have a y for sure. Since we at least have one, we need to list them. Y-intercept is at 0, 1, right? What happened to my line? And then our x-intercept, we said it's never going to cross that x-axis, so we would put none. Intervals of increase. I'm going to put my line back on here. I don't know what happened to my line. So I'm going to draw them back on here. Oh my goodness, that was bad. Try again. That's a little more accurate. Okay. Intervals of increase. Well, as we go left to right, it is always increasing. So that's our negative infinity to positive infinity, right? All the time. And decrease, we have no decreases. So a little bit different on that one. Okay, so in this one, Marcus bought, oh, you know what I was going to add on here? Let's do one more thing on here. I am going to put something that's called end behavior. As x decreases, y approaches 0. That would be an end behavior because we want to point out that it will get a little lower and lower and lower, but it won't ever hit that. All right, next. Marcus bought a $900 couch on a 6-month interest-free payment plan. He pays $50 each week on the loan. Describe the key features of the relationship between the number of weeks and the amount owed on the loan. So if we look at this in terms of, I'm just going to rewrite this up above. Let's change our colors again. We have $900 couch, and he's paying $50 per week. Okay, so that's kind of our information that we can remember for this. So what that looks like, if we were to draw a graph of this, he's owing $900 up here, right? And then as he pays it down, When does he pay it off? Well, $50 after 2 weeks, he'll have $100 paid off, right? 50 for the first week, 100 for the second week. So basically it takes 2 weeks to pay off every 100, which means it's going to take him 18 weeks to get finished. So to be able to do our domain, we do have a set amount here. And what that looks like, I'm going to have to draw this one, is we have certain numbers, right? It's not just every number being between 900 and 0, or every number between 0 and 18, but it's only whole numbers, right? It's going to be 900, 850, 800, 750. So we have to use set notation for this one. We have a variable, and the variable has to be whole numbers, and they have to be between 0 and 18. So we have a couple of criteria for our domain on this one. Range. Range is the same idea. Those were the 1, 2, 3, 4. Now it's the 900, 850, and so on. So Y has to be whole numbers as well, right? But this time, these have to be between 0 and 900. So it's only whole numbers between 0 and 900 that will be able to be used. So we don't have to list them all individually, but we do have to note that it is certain numbers in a certain range. Okay, so our maximum is $900 at 0 weeks. The minimum would be $0 at $0 at 18 weeks. Intercepts, we do have them. So our y-intercept is right up here at our 900. So 0, 900. Our x-intercept is right over here at the 18. So 18, 0. Intervals of increase. Are we ever increasing? No, we are not. So that is a none. Intervals of decreasing. It's always decreasing. So it's our whole range. It's including 0 all the way up to 18, right? That domain is always increasing. Is this a function? Yes, it is. Every week has its own value. And is this discrete or continuous? It would be discrete because we said it was that 900, 850, 800, 750. Okay, next. We have 5. So now we have a table that represents a continuous function defined from 0 to 6. So what I'm going to do over here is just kind of do a rough little graph of what's going on here. Looks like I'm mostly positive. 0, 4, 5. That's 6. And then we go from -3, so down here, up to 20. So we're just going to kind of do some lines up here. All right, so a first point on here. Oh, let's see, I don't want to do that. Sorry. Our first point on here would be 0, 2. And then we'd go 1, -3, 2, 0, 3, 2, 4, 6. Okay, and so then they're just getting bigger, right? And it's continuous. So my line is going to go like this, no arrows, because it's just from 0 to 6. So this gives me a little bit of a visual. So as I'm trying to fill these in, I've kind of got an idea. All right, so domain. I think it's pretty good that I got 0 to 6. They've already told me that in my original up there. Pull that back down. My range. So now it's not necessarily in order because I have a -3 after a 2, but -3 is my lowest. And my highest out of all of this would be 20. So that's my range. My maximum is going to be clear up here at my 20. So 20 at 6. My minimum is -3 at 1. And then my intercepts, let me just make sure I have enough room here. My intercepts, if I notice, they are listed right here. So I can note that here is an intercept and here is an intercept. So I can go back over here, and my y-intercept is when x equals 0, it's 0, 2. And my x-intercept is right here. When x equals 0, it is 2, 0. Intervals of decrease. Here's where I can do my lines again. I was using yellow, I believe, for decrease. So this stretch right here is a decrease. And this stretch right here is an increase and a decrease. So if I'm going over here to do my intervals, we start with an increase. That is going to be from 1 all the way up to 6, right? And I am not going to include 1, but I can include 6 because my interval of decrease starts at 0 to 1. And I want to include 0, but not 1, because that's where it switches around. All right, I don't think there's anything extra on this guy. Let's go to the next one. A couple more here. This is the one I was thinking of. So as we're going through on this one, I just want to note something. So notice how this one is coming down, and when it gets to 6, the answer for 6 is 4. But when you start moving away from 6 to like 6.1 or 6.01, it jumps up here. So it is a continuous function in the sense that every point, there's not 2 right here. I said I'm going to use continuous. It is a function because this point is 6, 4, and then the next one starts right here. So there is only one y value for every x. It looks like it may not be that way, but it is. So let's go ahead and do our domain for this one. So it looks like I'm going from 0 to 21, and that is inclusive because they are using that. And my range, my highest is 10. My lowest, it looks like about 3.5, -3.5, and it is inclusive. So I'm just going to do -3.5, comma 10. 10 is my highest. So then my maximum was that 10, and that is at 0. So 10 at 0. Notice how I'm using my range as my maximum and minimums, right? And so maximum. The other point I'm going to make here, a relative maximum. So that's something that's mentioned a little bit. This would be a relative maximum, would be 9, because it's a high point compared to the ones around it, but it is not the highest point. So that is the absolute maximum, 10 at 0. A relative maximum would be 9 at 8. So just kind of let's type that here. Relative maximum is 9 at 8. Okay, so just so we know that we've got a couple of things going on there. All right, minimum. The -3.5 is at, let's see, 3.5, 18. Actually, it looks like it's a little past 18. Let's do like 18.3. 18.3, about. I might actually write an about here. About 18.3. Okay, intercepts. So our y-intercept is pretty obvious. It was at 10. So y-intercept is 0, 10. We do have two x-intercepts. And the x-intercepts, one is right here. So I'm going to have to estimate for this guy because I don't really know exactly where that's at, but it looks like it's past half, probably that, I'm going to say 14.7. It's about 14.7, comma 0. And the other one is right over here at 21, comma 0. So if you have more than one x-intercept, you have to note it. All right, so increase and decrease. I'm going to go ahead and draw them in. So my increasing ones are going here to here. Right on, I'm going to go right on this part. And then I'm going to follow this down, and we said it was like that 18.3-ish. And then this one, I'm just going to follow the line. Okay, so then decrease, be here to here. And then this guy all the way down here. So we'll start with increase. Oh. Interval of increase. So that's our 6 to 8. And that is, neither one of those is inclusive. 6 to 8 because it's in between. And then I'm going to do that 18.3, as I said where that was at. So 18.3 is not inclusive, but it does stop at 21. So I can put 21 in the brackets. Decrease. My whole thing starts at 0, so I can do that in brackets. 0 to 6. And then not inclusive. And then I got to go from 8. I know I didn't do my line right there. 8 down to that 18.3. So 8, comma 18.3 on this guy. And we were saying earlier, it is a function because that is not, those are not the same point. They are different. And this is what we'd call discontinuous because there is a y value for every x between 0 and 20, but there is a jump on here. So I do have to pick up my pencil, but I'm staying in that same x spot to be able to do it. All right. Next, 7 key features of the relationship we've got going on here. All right, so this one, let's read carefully. Describe the key features of the relationship between the number of hours of daylight and the day of the year in your town. So consider January 1 as day 1. The longest day of the year is about day 173, about June 22nd. The shortest day of the year is 356, about December 23rd. You may have to make some reasonable estimates for the number of daylight hours. So if we were to kind of draw a graph of this, we've basically got January right here, February, March, April, May, June, July, August, September, October, November, December, right? Okay, so what it's saying is your days are getting, June is the longest day of the year, right? So this is the most daylight hours. And then December 23rd, somewhere over here, is going to have the least daylight hours. So that means we're getting longer as we go to January. We're getting shorter as we go to December. And then we go up just a little bit because the end of the year is not till over here, December 31st. So that's kind of the look of the graph. And we've got some specific numbers right up here. So let's keep this in mind. Oh, and by the way, I did look up some information on this as far as number of hours. So let's start with days. So our domain is our number of days. And we have 365 days in a year, right? And the range is our number of daylight hours. So I looked it up. It's about 9.5. We're kind of doing some rounding just to keep it easy numbers. Is the shortest day in Colorado. And 15 is the longest kind of in our area. So that's what we're going to use for ours. So then our maximum, when we're looking at it, we have that 15 hours on day. And what does it say? The longest day of the year is about day 173. So we're going to use that 173 right here. And our minimum is going to be 9.5 hours on day, and it says the shortest day of the year is 356. So we're going to use that information for here. So intercepts, we never have 0 hours and we never have 0 days. So there is no intercepts for this. And so then our increases, if we go look at this, we have an increase right here, and then we have a little baby increase right here. And then our decrease is in between, right? Since our graph starts not on that, the way it was going. So let's go ahead. Oh, I didn't switch my text. Oh, well. Interval of increase. So we have from 1, and that is inclusive, 1 to 173, and that is not inclusive. And we jump back up again at 356 to 365. Oh, 365. So that one would be inclusive at the end of the year. So then decrease is that little chunk in the middle, from 173 to 356. And neither of those are included. So is this a function? Yes. There's only one amount of hours each time. And this one would be continuous on there. All right. So a little bit trickier because we just needed a little more information, but not too bad. All right, 8. So graph the function, then determine the key features. So I'm going to go ahead and do my little table over here. X is greater than or equal to 0. So I'm only going to use zeros. 1, 2, and let's just go to 3. All right, so if I put in a 0 for this, I get an answer of 4. Negative 2 times 1 is negative 2, plus 4 is 2. And I notice my slope is a negative 2, so I'm going down 2 each time. So that's a 0 and a negative 2. And if I go one more, it'd be negative 4. So I see as I'm doing my graph here, I'm going to have mostly positive x's because I'm starting with 0, but I'm going to have a number of negative y's. So I'm going to make my space go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. And then 1, 2, 3, 4. 1, 2, 3, 4. Negative 5, 6, 7, 8, 9, negative 10. Okay. So when I go to graph this, I want to dot at 0, 4 and 1, 2. And basically, 2, 0. I'm going to go down 2 over 1 to get my next points, right? So if I get my line out here, should be able to do from here and cut through all those corners and keep going, right? And then I can put my arrow on the end. Not on the left side, but on the right side. So that makes my domain. I start at 0, but then I'm going on to infinity. And my range then goes from negative infinity all the way up to 4. So now I can use my text boxes. Maximum. So my highest here is 4 at 0. My minimum is a none, right? It's going to go on forever. And my intercepts, I do have 2. Skin that up. Y-intercept is 0, 4, 0, 4, and my x-intercept is 2, 0. Intervals of increase, I am only going downhill, so this is a none. And intervals of decrease, 0 all the way to, it's not gonna let me do it. I really think it should let me do it. Don't know why. Huh, okay. To infinity. Oh, negative, nope, infinity, right. Decrease, because it goes on forever. My x's. All right. I do want to do my ready for more right now because I think this is important to be able to kind of undo kind of what we're doing. So I want to draw a graph of a function with the following features. I need 2 increasing intervals, 2 decreasing intervals, a relative maximum of 4, a relative minimum of -4, and another of -3. And it's continuous and has the point 0.02. So I need to make sure that my points are hitting some of these. So I need to make sure it goes at least up to 7 and -5 on my, nope, bumping stuff. I'm just going to make this right in the middle. 7 and -5. So I'm going to do this line right about here. 1, 2, 3, 4, 5. And then I need 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. So I definitely need a point at 0, 2. So I'm going to go ahead and put that on my graph. If I need a minimum, a maximum of 4, and I have a decreasing spot somewhere in here, then I need to probably have my highest point a relative maximum. So I need to have a spot where at least it doesn't go, it does go higher than 4, but it needs to be able to go back down. So I'm going to do a high 1, 2, 3, 4, and on 3, I'm going to make my relative maximum. I think at -5, I'm going to do my relative 1, 2, 3, 4, 5, a relative minimum at -3. I think at 7, I'm going to do a relative minimum at -4. Okay, so I'm just going to kind of put some points in here because I know it has to increase from 7 forever. And I know it's got to have let's see, decreases. Well, I'm just going to do these as my minimum and maximum. So relative to whatever. Oh yeah, because it goes on forever. So it is decreasing from infinity, -infinity to -5. It has a relative maximum through point here at 4. It has to decrease from 3 to 7. That's a relative minimum. And then it goes on forever. So that is how I'm going to draw that to make it work for that. All right, last little bit. Helpful ideas. So just a few things that I feel like has helped us to be able to figure out some of these are one thing we did with our domains. Let's just note that domains, do this in purple, domains and range domain and range can be written in set notation if a list or limited numbers are used. Okay, so we don't have to use set notation just because, or interval notation if it's not a continuous function. Another thing we did was vertical and or colored lines can help mark intervals of increase or decrease. And then when you've got a table or something that's not necessarily what you're to be able to visualize. A lot of people are visual learners, and so graphs can help visualize intervals when given tables, equations, or stories. So a lot of those, even though we didn't have, I'm just going to back up a little here. Notice we didn't have a graph, we were given a situation, but we still drew one to kind of help us out. Same thing on this, just kind of gives us a visual to be able to help us out. All right, thanks for joining us today. That is all we've got for lesson 3. See you again next time.